No quizzes this
So
week.
rapid. I was.
All right, no quizzes this week. We'll do 5 today, 5, 6 tomorrow. We'll kind of review. Have a nice easy review day Wednesday. Talk about turkey.
I have a 6-day streak.
Good job, Liv.
Thank you.
Besides getting quarantined, I haven't missed a single
I
would say that's close.
All right. We are continuing our talk about triangle congruence today. You got guided notes in front of you. It's a good day to be here. The sun is shining. Beautiful. Perfect conditions to learn. All right. So what do we have so far for triangle congruence? If we get to, and I know if we get all three sets of sides and all three sets of angles, the triangles are obviously congruent, right? There's no doubt. But we want shortcuts. We want shortcuts. What are our shortcuts so far? It's pretty boring. SIS, right? And on that quiz, you're like, I see it. I know it's going to be SIS. I just need to get there. Easy. All right? Today we're adding 2 more to our repertoire. Are you ready?
No.
SSS and HL.
Height and length. Height and length.
We're flipping. Some are flipping. Can't wait.
Oh, rise up one.
Can't wait. All right. We'll talk about that later. Our learning targets today. We're not going to really. I mean, I think you guys would all agree the rigid motion thing is going to be true. What does that mean? If you can translate and reflect and get one shape to match up onto another, they have to be congruent, right? Rigid motions. I can use SSS, and then we're going to, I gave it away. Hypotenuse, leg. Hypotenuse, leg. But first, SSS is easy. It's obvious. Side, side, side. Now, this is a shortcut. Again, just like SAS, it has 3 sets of information, but not 2 sides at an included angle. 3 sets of sides. 3 sets of sides. SSS. But if 3 sets of sides are congruent, then the angles would have to be. Do we need to argue that, or is that pretty obvious to you? Pretty obvious? There's only if I give you 3 different lengths of toothpicks or straws, 3 different lengths, and I say put these together, and I give someone else 3 lengths of straws, and I say put them together. There's no other way you can put these triangles together that they would be different, right? They have to be congruent. 3 sets of sides match up. Do not confuse SSS with equilateral. It's not saying 3 sides in a triangle are the same. It's saying this one goes with that one, this one goes with that one, this one goes with that one. All right? Let's do a proof with this. Beautiful. These are easy. Here's what I'll say. The faster you can get over the groaning of proofs, and I'm just being completely honest, because in all honesty, if you don't like proofs, I don't really care, all right? No offense. But whether you like them or not doesn't affect me. I want you to do well with them, and I'm just going to give you a little word of advice. The quicker you can get past your emotions about something and start just dealing with it, learning with it, it sounds like stages of grief, doesn't it? Acceptance, okay? Acceptance. No. The sooner you can get to the point where you're like, okay, this isn't that bad, the better you will do on these. Trust me, I've done this for a while. All right. Ooh, set asides. I'm going to go ahead and write both of those on the first line. KL congruent to NL. KM congruent to NM. We're writing this down with me, aren't we? Right? Awesome. Now, they were nice enough to give it to us on the picture. I'm not going to promise I'm going to do that on the quiz. All right? But it's easy enough that you just put tick marks there. KL, NL. KM, NM. kind of spoiled it for us. They told us in the proof. They said, using the SSS congruence theorem. So, we're out of givens. But guess what? The same tips we used before are going to hold true for these. Olivia has her hand up. What do you think?
LM is congruent to LM from reflexive.
Ooh, LM congruent to. Now let's double check the order. Ready? LM. I like it. She says reflexive property. So, are we to SSS or SAS? Those are our only two tricks right now. Yeah. Yes. So, triangle KLM congruent to triangle NLM. And our final statement is SSS congruent. Side. Three sets of sides in one triangle congruent to three sets of sides in another triangle. That was easy. Come on. Do you agree? That was easy. Let's do another. Ooh, less groans that time. I like it. All right. PT congruent to RS. I'm going to mark it on the picture. PT, RS. QT. Aw, what a QT. Congruent to QS. Given. That was an ugly E. All right, QT. QS. Given. Now, I could write the other given on the same line, but it's a different topic in my mind. It's like a different train of thought. You've heard that expression, right? Train of thought.
Yeah.
Yes. Okay. So do you agree? Like these were they gave you a couple pairs of sides. Then they start talking about midpoints. I'm going to write that on a separate line just because it has a separate result. Q is the midpoint of PR. That was given. Now, this is a two-step. If they tell you it's a midpoint, you have to say it's a midpoint. Then you have to say the result of the midpoint. Who wants to make me proud? McKenna.
RQ is congruent to PQ definition.
Nailed it. RQ, and she even nailed the order. I think you said RQ. You said PQ, didn't you? PQ. That's the definition of being a midpoint. You guys all right? You have a question? Definition of midpoint.
Can you do angle PQT is congruent to angle RQS from the definition of midpoint?
That's a good question. It's worth talking about. Did you hear what she said?
No.
I understand when she starts talking, most of you tune her out. I understand, but I'm so mean. All right, ready? Let's build the picture and see if we can make a counterexample to what you're saying. And this is kind of what you should do in a proof. If you're like, is there ever a scenario where that's not going to be the same? Okay. Is Q my midpoint here?
Mm-hmm.
All right. Now, your statement was that this angle and this angle are congruent. Agreed? Is there ever an example where that's not true? That goes through a midpoint? Is that angle congruent to that angle?
No.
Do you see how this angle where they meet can, I say pivot. It can pivot like that and force those angles to not be congruent? Do you see it now? Olivia, you know it. Do
Yeah.
you see it now?
Yeah.
It's worth talking about. That's a good question. Now, here's the. We'll get to it in a second. I don't want to confuse anything. All right. Well, look what we have. Triangle PQT congruent to triangle RQS by SSS. No vertical angles. No reflexive property. There's no overlapping sides. There's an overlapping vertex, but not overlapping sides or vertical angles. Do you guys agree with that? So midpoint is another one of those. Look for it. Look for it. It gives you a pair of congruent sides. All right, now here's what I was going to say. What if, because this is easy for most of you, what if the proof was changed to prove, let's talk about the Olivia angles. Angle TQP, I'm just making this up by the way, congruent to angle, TQPSQR. Prove the angles Olivia was talking about are congruent. What changes in the proof? Jared.
The next step would be CPCTC.
Nailed it. I knew I could count on you, Jared. Ready? Everything's the same. Oh, look! The triangles are congruent by SSS. Then the angles Olivia's talking about must be congruent. This is not on your proof. I'm making this up. By CPCTC. Oh, look! The triangles are congruent by SSS. Everything else in the triangles we have not talked about are congruent. S is congruent to T. Angle S is congruent to angle T. Angle R is congruent to angle P. And angle TQP is congruent to angle SQR by CPCTC. The triangles are congruent, so the corresponding parts of those congruent triangles have to be congruent. CPCTC. Tell me.
Will something like this be on the test?
Absolutely. It's not bad. If you watch, I'm going to make this very simple for you. If you prove that the triangles are congruent, you stop at SSS or SAS. You stop. Understand? If you prove a pair of angles or a pair of sides, parts of the triangles. If you're asked to prove a pair of parts of the triangles, angles or sides, you still prove the triangles congruent by SSS or SAS, but you have to go a step further and say, oh yeah, now those corresponding parts are congruent. Does that make sense? It's one extra step. How will you recognize it? If they say prove angles or sides congruent. Triangles, SSS, SAS. Stop. Beautiful. Beautiful. All right. Our next shortcut is hypotenuse leg. All right. Hypotenuse leg. You're going to write it down, and then we're going to talk about serious danger. Danger is its middle name. And risks for detentions. Ooh, the plot thickens. Oh my god, detentions. That's nothing. Right, Levi? This is a very special case. It does not happen very often. Because what kind of triangles is it only used for?
Right triangles.
Right, that's right. Tally.
What's a hypotenuse?
It is the side across from the right angle. Is that word new to you guys?
It's the long.
Long.
It's the longest side, yeah. But
We learn about it, but no one says that word.
I don't think I've ever learned about that.
I've never heard of hypotenuse in my life. I just know that's how you pronounce it.
I've learned slow very
all right, I appreciate you being honest. I appreciate you being honest. Sometimes too honest. All right, here we go. Right triangle. Oh, I want you to change dimension. There you are. There you are. All right. This is the right angle. I guess we have to work on some vocabulary. I'm going to teach you some vocabulary today. All right? You know that's the right angle. These are called legs. The legs meet at the right angle. If you don't know it, I would write it down. I did not know you did not know this. So if you don't know, I would write it down. Those are called legs in a right triangle. So in this triangle here, who can raise their hand and name a leg? One of the legs. Let's go with Christian. Leg. Legs. You said BA? Yeah. Thank you. And Ryan, do you have your hand up?
Yeah.
Go for it.
AC.
AC. Doesn't matter how the triangle's turned, the legs meet at the right angle. Hey, right angle. Hey, right angle. Let's meet together. All right? Two legs. Two legs. They're not always the same length, though, are they? Right? Right. So, where is the hypotenuse? The last one, the one that doesn't touch the right angle. And the problem with saying it's where it's slanted is that as this triangle turns, nope, that's not how I want to draw it. Ignore. All right. As the triangle turns, like say this is the hypotenuse. So let's make, I'm going to run out of room there. Oh my gosh, I cannot draw this. We're going to make this very simple. Boom, nailed it. All right, as we turn the triangle, there's the hypotenuse, right? So we can't say it's the slanted one, it's the straight one, it's the whatever. It's the side across from the right angle. What does across from mean? Not touching. Not touching the right angle. It's the only side that doesn't touch the right angle. Got it? Awesome. That's the hypotenuse. It's always the longest side. We already talked about that two angles in a right triangle have to be complementary. Agreed? They have to add up to 90. Well, we already have a 90. You guys need to really listen to this. We're really going to dive deep into this for whole chapters, okay? If we already have one right angle and the other two are complementary, doesn't the one that opens up to a right angle have to be the biggest angle in a right triangle? The right angle is the biggest angle. The one across from it has to be the longest side. Because think about it. What if I open up to a small angle? Ooh, small side. Big angle, big side. Just like the longest side in a triangle is always across from the biggest angle, right? That makes sense, doesn't it? Okay, well, so what about this? Well, this is only for right triangles. And here's what this says. If you have a hypotenuse and a leg, a hypotenuse and a leg, congruent in two different right triangles, the triangles have to be congruent. Does that make sense? Okay? Do not call this SSA. Or even worse, detention worthy. A S S. Do not do it. Do not do it. I'm not even gonna write it on the board. Okay? If you write on your paper, I will make fun of you and then write your detention for swearing on your papers. Tally, don't do it. Chase, did you do it?
I only wrote one test.
Close one. All right. So that is not a congruence
could have said yes.
statement. We'll have to save that for another day. All right. But this is a right triangle. If you write, and by the way, these work forward and backwards. Guess what SAS is backwards? SAS. SAS. SAS.
Wow.
Guess what SSS is backwards?
SSS.
Brilliant. You guys are sharp. All right.
Smart.
So,
You wrote it, so I can't tell you. I think I can see it now.
this is not one of them. This is never going to be one of them. You'll get a detention because it works forward and backwards. And it is not one of the congruence statements. All right? Are we okay on that? So what is this then? It's a special case. It's a right triangle. It's called hypotenuse leg. Hypotenuse leg. Got it? Got it. All right. Is this one one in yours?
Yeah.
For some reason I forgot to put the thing there, the 2 columns. Let's see. Come on.
Use a RIP lot of water.
That's weird.
I can remember one of them.
Old school.
I can remember one of them.
All right. Let's do this one together.
Just to remember.
WY congruent to X Z. Are we going to write all the 3 givens on the same line or separate them?
Yeah.
Yeah? Okay. How about we do them in different colors, though? All right, we got a pair of given segments congruent. I put those in blue. And then we have a couple sets of perpendicular segments. Now, perpendicular segments does not tell us they are right angles. Do you understand that? We have to do some work. You understand that?
Oh, is that one parallel?
Nothing's parallel. Oh, I see what you're saying. Ooh, you know what? That'd be tricky. I could do it that way. I'm not going to. But we could.
No, I don't know what I'm talking about.
Really? Because you kind of got me thinking. I would have never thought of that. If consecutive interior angles are supplementary, then these lines are parallel and you could do alternate interior.
I
Wow.
just thought if they were parallel.
Olivia,
That is a lot of
not only are you here,
way too fast right now.
you accidentally did something amazing.
Right.
All right. Now, if we have perpendicular segments, we need to say that they form right angles. Okay? And this is the annoying part of geometry. It's like, Duh, they're perpendicular. You mark them as a 90-degree angle. Why can't we just say, oh, it's there, done? Well, we have to be thorough. So we have to say, and this is the annoying part, angle WZY and, in words, angle XYZ are right angles. Because that's the definition of what? Perpendicular segments. And then another annoying step. Now that we've said they're right angles, we have to say they're actually congruent. By the?
Right.
I think it was Caden in here that did it last week, right? No? Who? That was Jared?
Yeah, that was.
Sorry to steal. Sorry, I didn't mean to like deflect some credit there. The right angle congruence theorem that says all right angles are congruent. Duh. Stupid. Press it.
Can I switch?
Yeah. Finally, now we have a pair of congruent angles. Pair of congruent angles. They gave us a pair of congruent sides. So this is in the proof. Now, this one's obvious because we just learned what HL was when we're practicing HL. You're not going to have that benefit. You might get to a proof where you're like, oh, wait, am I going to use SSS here? Am I going to use SAS here? Am I going to use HL? I don't know. So in this one, we have the benefit of knowing, but pretend you didn't. Do you agree you might still try to keep going with SAS? Because we have an angle and we have a side. Do you agree? Okay. One red flag. SAS. SAS. The A has to be where? Between the two sides that you have shown tick marks on, right? SAS. Okay? And I guess one red flag here would be there's the right angle, and the side we know is congruent is the hypotenuse. It's not one of those where they come together. You see what I'm saying? Okay, so we're starting to think, maybe not SAS. Maybe HL. All right, well, let's see what we got here. Those blue sides, are those the hypotenuses or the legs?
The hypotenuse.
The hypoteni, right? The hypoteni. So what do we have left to prove? A pair of legs. Pair of legs. Which legs are congruent? WZ and XY, I hear. What would be your reason? Still taking answers. Tally, what do you think?
Would it be SAS? Because it would be like vertical angles. I don't know.
It's not SAS. We're going to be doing HL. Okay, if you're thinking vertical angles, and this comes up quite a bit. Watch up here. Always up here. If you're thinking, oh, there's a pair of vertical angles. Yeah, but those aren't any of the angles in the triangles we're talking about. WYZ is this triangle. It has this angle, and that angle. All right, it's three angles, not that one up there. Does that make sense?
Yeah.
So, I've recommended it before to kind of outline the triangles you're proving are congruent. It might help your eyes see which ones you're trying to prove. So here's our options. I'm telling you it's HL. I'm telling you right now it's going to be HL. Spoiler. Is it this leg and this leg, or this leg and that leg? That's it. Do you see it? She had a light bulb, huh?
Absolutely.
You do? You're not giving me sass. McKenna.
So I probably wrong because I'm like, I don't know. So is ZY here to ZY to reflexive?
It is.
Oh my gosh. Wow.
Do you see it?
No. So wait, no.
Yes.
No. It's ZY and YZ.
No.
All right, hold on.
Tyler knows what he's talking about.
I'm giving her credit because she's the only one that's put her hand up and answered it. Okay. But let's check the order, guys. Stop talking. Let's check the order. Ready? Let's call this red triangle, triangle 1. And it has vertices of W, Z, and Y. Let's call this purple triangle, triangle 2. It has vertices of X, Y, and Z. Okay? Now, in this picture, they're overlapping. I pulled them apart. Is the correct order Z, Y, Z, Y, or Z, Y, Y, Z? Yep. And the other way you could check in case your eyes are deceiving you, watch up here. If we say Y, Z over here, it's Z, Y over there. They have swapped places. Do you see it? Reflexive property. Now, we have seen the reflexive property used when triangles are sharing a side like that. But guess what? That's right, Ryan. That's right. That's right. But they're also sharing a side here, aren't they? They're also sharing a side in this one. You guys all agree?
Yes.
Sharing a side. Reflexive property. Are we there yet?
Yes.
Let's see what we have so far. We have that and that. We have that and that. And we have that and that. Oh, look. It's a right triangle. We have a pair of blank congruent legs. Always good to have a pair of legs congruent. You're hobbling down the hallway, do not. Yeah, right. And then a pair of. Go ahead. You want to say it? We already have legs congruent. Hypotenuses. Hypoteni. All right. I don't know. I think I made up hypoteni. Ooh, that's a weird triangle. W Y Z. W Y Z. Congruent to triangle. W Z Y.
Oh, Paige, you're not bringing it.
By H L. I'm just warning you right now. Don't try to overuse HL. It's very rare. It doesn't happen very often. It's that friend you call up only if you have no one else to hang out with. Yes, Paige.
I answered that friend, but
I did?
Yeah.
Where?
You put WYZ and WZY.
They only text you secrets.
WYZ.
I mean, I don't blame you. But I've heard her.
WYZ. Thank you. Thank you. This is supposed to be an X.
Never, not before you text me.
This is supposed to be an X.
My dad.
Why? I heard someone say something that's wrong. Why is it not SAS? It's okay. You on it. Why is it not SAS?
Okay, no, that's not what I was saying though. What I was saying is because
Guys, this is so important. We're about to build all 5 SSS, SAS, ASA, AAS, and HL. 5 of them we're going to have by the end of next week. Why is this not SAS? Paige.
Because
say something where the angle has to be in between them.
Thank you. If this were SAS, we'd have to have this angle and that angle congruent. SAS, SAS. It's the right angle is the non-included angle. You see it? So if you're to say, hi, I'm a congruent side. Hi, I'm a congruent side. Let's get together. Okay? Where these get together, that's the angle that has to be congruent. Not down here. It's not included. Story of my life on the weekends. All right? Do we get it? All right. It's half of a joke. Okay. Ooh. Last one for today. PQ. Congruent to RS. Given. Now they got us a step closer on this one. They told us angle Q and angle S are right angles. That's nice because then we only have one step to get to they're congruent, not two steps. Do you understand what I'm saying? If they said they're perpendicular, we have to take a step to get to the right and then another step to get to their congruent. If they told us they're right, now we can just say that they are congruent. Jared, I'm not going to steal your thunder this time. Thank you. The right angle congruence there. The racked. And we already have PQ and RS. We're out of givens. We're out of givens. Now we have to look to the picture. Look to the picture. Let's go with some new. Oh, Anthony, go for it.
RP, PR,
RP, congruent to PR. Is that the right order? Let's see. R, P, P, PR, yeah. Reflexive. Not SAS. HL. Triangle. P, Q, R. We're going to triangle. R, S, P, H, L. Now again, even though we practiced it a few times today, don't use it to, it's not going to happen too often. All right, tap.
You know how you said with the Z thing? Like you
The what?
You know how you said if there's a Z or something like I use SAS? How do you tell if there's
Nope.
like how you
If you have a Z and you have parallel lines, you're going to use alternate interior. All right. All right, homework's up there.
And then I asked a question.
I'm just not
I know, it's like,
you guys are bringing on
I
the
had to write for the test on Wednesday. And I was like,
He was like different.
I didn't use like